Alright, our next little group of problems. The first thing they ask me is, how many 8-letter words, real or imaginary, can be made from the word calculus? So it's 8 letters because there's 1, 2, 3, 4, 5, 6, 7, 8. So you start out, it's going to be 8 factorial divided by. If there were no repeating letters, the answer would be 8 factorial. But some of the letters are repeating. I suggest that you just go down the list. C's. How many C's do you see? I think there are 2. So a C and a C. And then the next letter is A. How many of those are there? Just 1. So that's gone. How many L's are there? Looks like there are 2. And then how many U's are there? Also looks like there are 2. And I believe there's just 1 S. These numbers should add up to be 8. 2, 4, 6, and then 8. So any number that's not 1, like these 2's, you need to divide by those. 2 factorial, 2 factorial, 2 factorial. And then you just do that in your calculator. So you're going to say 8, and then you go to math. The factorial key is by the probability line. It's the 4th one down. So I said 8 factorial divided by, now you need to put the bottom in parentheses, 2 factorial, and then I need another 2 factorial, and indeed I need 3 of them, so then I go 2 factorial. I'll close my parentheses to be neat and tidy, and I get my answer is 5,040. 5,040. 8 factorial divided by 2 factorial times 2 factorial times 2 factorial. And that's your answer. All right, next little question here. It says, in a probability model, which numbers could be the probability of an outcome? The rule is no negatives, and it can't be 0, but they can't be negative, and they can't be bigger than 1. So I'm going to circle all the ones that can be. 0.2, perfectly good probability. Negative 0.01, no, because there's no negatives. 1/5, perfectly fine. Negative 1/3, no negatives. 1, perfectly fine. 1.3, too big, can't be bigger than 1. 0.01 is fine. 4, too big, can't be bigger than 1. So the only ones I have that are good are 0.2, 1/5, 1, and 0.01. All right, next little group of questions says, is this a probability model? Do these represent probability models, yes or no? The rule is the probabilities have to be acceptable and they need to add up to be 1. So what the outcomes are, the probability of black is 0.2, probability of white is 0.3, probability of green 0.1, probability of blue 0.4. If you add those up, these add to be 5, these add to be 5, so they all add up to be 1. So we would say, yes, this is a probability model. The next one says pink, yellow, purple, and red, and the probabilities of those are 0.1, 0.3, 0.2, and 0.2 respectively. But if I add these together, this would be 0.4, 0.6, 0.8. They only add up to be 0.8, so this does not represent a probability model because the probabilities have to add up to be 1.